And there we go.
Pointer go here. Okay, well, thank you, Eric. Nice to be joining everybody at their desk this afternoon, or this morning, while I'm sitting at my desk at my home in Davis. Eric helped me come up with title and sort of the structure for this presentation. And I'm paying full attention to those questions as you'll see as I go through my slides. I'd like to acknowledge my colleague Meg Sedlak, who's the program manager for the Regional Monitoring Program and the lead scientist. We work very closely together, and along with a staff of folks at the Estuary Institute managing the monitoring program. Time tends to fly when I'm giving talks, so I would prefer for larger questions to be saved for the end. If you have sort of quick clarifying questions as I go through, go ahead and send those. Okay, so I'll get started. So, as I said, Eric gave me a list of questions that I should try to answer, and the part of the first question is, what do you do? I'd like to give a quick look at what the program is currently planning for 2012. Start with a look at the money that goes into the program, the different categories of the RMP. Get up into the categories shown on the slide. Status and trends is part of the program, 32% of the budget. Recently, special studies became the largest component of the program, and I'll tell you about all the special studies that we have planned for next year. Program management, administrative tasks like contract management, financial management is about 16% of the budget. Operations is 8%. Data management and QA is 5%, and then there are other sort of miscellaneous costs that account for 6% of the program. RMP has been in existence since 1993, and we have generated mountain information, and so it's hard to decide what to show like this in a short presentation. I decided that I would give you kind of what we're currently up to, like our plans for 2013. I'll show you a little bit of the results that we've gotten from our past sampling, but I'll show you the cutting edge of where the program is heading into next year. So I will start with status and trends and plans for 2013 there. In the status trends part of RMP, we do interannual trends in contaminant concentrations and other parameters in water sediment, bivalves, bird eggs, sport fish, and then we have a couple of elements that are based on more frequent sampling. The first elements there are annual sampling designs. We go in where we collect one sample per year, basically doing a survey throughout the bay. For water years, well, in the beginning of the program, we collected samples every year, and actually we were doing seasonal sampling of water and sediment. The emphasis was heavily on water and sediment sampling. Over the years, we've scaled back as we've gained information and kind of reached diminishing returns on characterizing spatial patterns in the bay for things like metals in water or metals in sediment or organics. We've gradually scaled back, and as I said, we've been putting more of the funds into special studies as time's gone on to answer more specific questions that aren't related to long-term stats and trend type monitoring. In 2013, for water, we've gone to sampling every other year, and the organics every 4 years. So we scaled that back significantly. The most recent round of scaling back was moving the organics to every 4 years. And so 2013, we'll be sampling metals, but organics, and we'll be sampling 22 locations. We'll do organics again in 2015. Sediment, we sample every other year, so we're 2013 is a year off. We'll be seeing in 2014 again, and we do metals, both metals and organics, every year. A twist for sediment is that we also alternate between wet season and dry season. Traditionally, we did a dry season sampling, and then in recent years we shifted to this alternating design to get some information on concentrations during the wet season. We look at organics. They're a great trend indicator for organics. We analyze, we sample the bivalves every other year, so this is a year off. First, we look at selenium, organics, and a lot of emerging contaminants. We do a 3-year cycle. In 2013 is a year off. The next, I don't remember the next year. I think it's 2014. Sport, we will be sampling in 2013. Oh, no, I have that wrong. I was thinking of 2014. That's a mistake. We 5-year cycle now. We've moved to a 5-year cycle and look at sport fish. We collect sport fish from 5 popular fishing areas in the bay and a large suite of contaminants. But not 2013, it'll actually be 2014. And then 2 parts of our status and trends monitoring that are done by USGS. One is led by Jim Clorn. He's continuing monitoring that he's been performing since the 70s. It's a great data that he's generated. And look, basic parameters, DO, phytoplankton, 86 sites that he does monthly cruises to collect that information. And I'll be showing you some of the data that interesting data have come from that. And Dave Schulhammer at USGS has been operating suspended sediment sensors at 6 sites in the bay. That's also generated some very interesting information over the term that the RMP is operating. Both programs go back to the beginning of the RMP. So now to some data. These are data from Jim Clorn, and he has documented a gradual increase in phytoplankton abundance in the bay, measured as chlorophyll, especially in South Bay, where the baseline level of chlorophyll are increasing. You can see kind of the inks here in the baseline, and then the being of the phytoplankton blooms has been variable also over the years. Overall, it's a doubling of annual average chlorophyll in South Bay. And then looking at, specifically in the summer months, there's a striking increase from the 90s to the present, 100% increase in South Bay since 1990. This has been really important information that's led to a lot of concern that the bay, which has historically, the bay has high nutrient concentrations compared to estuaries, but we're fortunate that concentrations don't lead to problematic algal blooms. There's concern that the resilience of the bay may be decreasing things like increasing clarity, web shifts, and others, and that we may pass on eutrophication in the bay may not continue. So this has big implications for wastewater treatment, and there's a lot of energy going into understanding this and into understanding nutrients in the bay. Suspended sediment trends have also been really interesting, and there was an unexpected sudden drop in suspended sediment concentrations in the bay in 1999. And I'm showing data for one station here. The dots show the average concentration, and then the range is shown in green for each year. But there was a 30–40% drop in the late 90s that has persisted to the present. And the hypothesis is there was a pool of erodible sediment related to hydraulic mining that has. The hypothesis is that pool has worked its way through the system and has now been flushed out of the system. That's Dave Hammer's theory on why we've seen this drop. There's a nice paper on that he published. Some of the contaminant data we generate these that we publish in the Pulse and in our other RMP update document. That methyl mercury in water, as an example. The contours are based on the full data set. In this, we started getting methyl mercury data in 2006 in water. And the points on the graph show the most recent sampling year. So the dots and the diamonds are from 2011. And the inset graph shows the time series for the bay-wide average for each year. And there's an intriguing apparent drop in methyl mercury concentrations in water in the bay. Whether this is a real long-term trend, I'm starting to believe with 4 years in a row showing a similar bay-wide average. But what may be causing this is unknown. It doesn't seem to be translating into changes in concentrations in the food web. But one of the factors that affects methyl mercury is water clarity. Photodemethylation is a major pathway. So whether this may relate to the increasing clarity of the bay is a hypothesis. Okay, so now I want to start talking about the special studies that we're doing, that we have planned for 2013. And you can see the latest and greatest studies that are going on. And again, this is a big part of our program. On an annual basis, we put a lot of energy into identifying, planning these special studies. The first area where we are doing this small tributary loading is one of the big priorities of the program, characterizing loads. We are doing watershed load monitoring. We've the local watersheds around the bay are we've gained better information on relative importance of these local watersheds versus this valley watershed, the big watershed that feeds into the bay. There's a shift towards in our understanding, and the local loads are actually greater than the loads coming from the valley for many constituents. Coordinating this with the municipalities that have a municipal regional permit to stormwater, and overall, there are 6 watersheds being monitored for loads. The Army funds are covering 2 of the watersheds, and in each of the watersheds, 4 storms per year are being measured for a list of pollutants that you can see on the screen. We're also developing tools to evaluate loads from all the watersheds. We can't monitor all of them, but we can extrapolate based on the watersheds we are monitoring and based on watershed characteristics like land use and runoff projections. And we're compiling all this information in what we call a regional watershed spreadsheet model. That we're in the 4th year of developing it. In 2012, we have been working on copper load estimates, and in 2013, planning on doing estimates for mercury and PCBs. This is feeding to the watershed, the spreadsheet model are event mean concentrations from particular land use types or particular source areas, and we've been getting information on these concentrations through empirical field studies, and we'll be continuing to do that in 2013. Nutrients is another major part of the program, increasing due to the increased concern about bay phytoplankton populations. In addition to Jim Cloran's work, we are doing special studies, pilot work with moored sensors, where we're hope to be able to characterize the shorter variability, finer scale temporal variability in nutrient-related parameters, such as those listed here. We are also doing some pilot work with microcystin on fat, which are passive sampling devices that can be used to look at toxins, and we're using these devices, deploying them both in our cruises and at fixed stations, and then we're also funding Rafe Kudela at UC Santa Cruz is doing this work to do some validation and calibration to help us understand the relationship between concentrations in these devices and concentrations in water. The graph here shows some data from the South Bay on the left and around the El Piso area, from Moss Bay, and then from the Delta area. So we are seeing microcystin essentially throughout our system, and this is why we've decided to investigate this further. We're also at nutrient loads in those stormwater loading studies. We've added nutrient parameters to those, and then we're also developing an overall summary of nutrient loads to the bay. Modeling, and this the driver of our interest in our work is nutrients, developing the capacity to forecast condition the bay under different management scenarios. Contaminants, there's also interest in being able to make forecasts for other contaminants. The primary driver and other contaminants like PCBs and emerging contaminants are kind of secondary drivers, and there's a lot of modeling going on in the bay, and having these multiple objectives is a challenge. So we're starting by developing a very thoughtful tactical plan for developing these models and trying to develop a framework that can cover all of these different water quality parameters. So that we're working on right now, and then in 2013 we'll get started on developing the hydrodynamic and sediment transfer transport model, actually building the model. And one initial will be to develop a model for nutrients in Suisun Bay and South Bay. It's recognizing that with a high-profile ecosystem like San Francisco Bay, we don't have this capacity yet. So we're hoping to get that need addressed. Work on emerging concern, and we've really been at the edge of all of this work. For 2013, we're going to be writing a summary report on the PBDE work that we've been doing in the Bay. The graphs here show that we've seen declines in PBDE concentrations in Yoda that seem pretty striking, and time will tell if these continue the future in our real declines, but they show that way, and they are coincident with bans on some of the classes of PBDEs. And octa mixes, the deca mix is slated to be phased out as well. So it seems we are docking a decline here on these what were considered emerging contaminants 10 years ago, and there was a lot of concern. Now it seems like they're contaminants of diminishing concern. A strategy for monitoring CECs in general, that we try to identify all the CECs that could be potential problems in the Bay. So we have a strategy document that we're updating in 2013, and update basically continually. And then another area of focus is current use pesticides. We're going to get a group of experts together to help us identify which of those chemicals might be worth monitoring in the Bay. Another EC study, and this also connection with effects work in the program, is developing development work with bioanalytical tools, which are basically either in vitro cell assays or assays with in vitro assays with organisms like fish that allow you to measure for an effect endpoint rather than a particular chemical. So it's a non-targeted approach that helps you screen for classes of chemicals like estrogenic chemicals. So the study that's being done is developing this work, linking in vitro and in vivo assays, so that we can know how the in vitro responses relate to responses in fish from the Bay, where the work will include laboratory work with a species that is found in the Bay. So this pretty detrimental example of sometimes the RMP is not just routine monitoring. We do actually get into some cutting-edge research areas in some of our work. Another effects study that we're doing in 2013 is developing a benthic index for mesohaline waters in the Bay. We don't have an index that allows us to assess whether a particular mix of benthic species is indicative of healthy or unhealthy conditions yet. We're getting experts there to help us develop that index. This is important because a lot of the Bay is mesohaline habitat or lower salinity. All these yellow symbols in San Pablo Bay and then in South Bay indicate where the mesohaline habitat is. Finally, one other effect study is looking at the use of copper on salmon olfaction, which is work being done by NOAA, and we're getting outside funding from Copper Development Association to help expand the work that the RMP has funded. We put a lot of effort into communicating, into turning data into information and trying to get that to the people that need the information. The list of products is shown here. I don't think I'm off. But I put a lot of effort into this, and I will talk about the latest document, which is the monitoring update, a little later in the talk. So I'll be coming back to this and give you more information about how to access all of this. We have a massive database, 9,000 records since 1993, and we have a tool that we call CD3 for distilling and downloading data through a map interface. And this website got 1,600 queries in 2011. Worked closely with state on these data management efforts and CDIN. All data get transported over to CDIN. So is there another resource that may be useful to some of you? So what we do, now about why we do it. The goal of the program is articulated here. We collect data, communicate information about quality in the Bay in support of management decisions, and we really try to keep a sharp eye on generating information that supports management decisions. It's really a key criteria that help us decide which studies to pursue. We have a framework, an overarching framework of management questions. We have level 1 questions, which are most general, and basically they boil down to concern impacts, spatial distribution, sources, pathways, loadings, and then projected conditions. There's a series of questions under each of those that get a little more detail. We try to keep that focus on supporting management. So in order to do that, we think carefully with our stakeholders about what the long-term management plans are and what kind of information will be needed, not just what the needs are today, but what the needs are in the future, so that, in the words of Wayne Gretzky, we can skate to where the puck will be, not skate to where the puck is. If we hope to inform the plans for 5 years down the road, then we need to have an idea of what they are so that we can generate the information and inform those plans at the right time. We look at the long-term plans. We turn them into management questions with our committees and our work groups. Then we generate the information and the theory that this leads to enlightened management actions and ultimately a cleaner San Francisco Bay. So the structure shown here, the steering committee makes all final decisions. It's a group of stakeholder representatives at sort of a management level. We have a technical review committee that is responsible for providing technical oversight for all of the elements of the program, again with representatives from different stakeholder groups and the board and all the discharger groups. And then we have work groups where we again have stakeholders, but then we invite some of the lead scientists from these different fields, sit on these work groups with the stakeholders and with the SFEI scientists, and help us by basically providing peer review throughout the entire process of a study from the conception phase, the plan phase, through the implementation phase, and then they also review our final products. Got some of the world's experts on these topics sitting on these work groups, and built-in peer review is, I think, a real key to the success of the RMP. We have really good discussions in these work groups that they're fun to participate in. So we have 5 of those, and then we have another 5 strategy teams where we stakeholder groups that identify the priority management questions on particular topics like small tributary loads or mercury. So we've got 5 of those as well. So a lot of planning that goes into the program. So how can it come about? To answer this, I'm taking a couple paragraphs from one of the NPDES permits. This is the NPDES permit for East Bay Municipal Utility District, one of our big discharges. And it references the history of the program. So the program initiated when the Water Board adopted a resolution directing the executive officer to implement a regional monitoring program. Then had meetings to figure out how to do that, and then the board staff issued a 13267 letter to report on water quality of the estuary. And the way this has been countered, borne out in the in the current time is the NPDES permits have this provision that the discharger shall monitor or cause to be monitored and receiving water for toxic pollutants, or they continue to participate in the RMP to provide characterization. When the program began, there was a trade that was made where the dischargers were allowed to reduce their monitoring their receiving waters. Were given some slack there, and then the resources from that freed up were put into RMP for a coordinated effort to characterize the whole bay. There's a hammer here that the dischargers they can opt out, but there is this requirement that this type of monitoring needs to happen. So this translates to the funds coming into the program, these permit provisions, and the NPDES permit holders are contributing, including. So you can see here the different groups: the municipal wastewater treatment plants, industrial, stormwater, cooling water dredgers, and the Corps of Engineers. The relative proportions that each group contributes have been held constant since the program began. Each group, the dredgers are figure out for themselves how to apportion the fees that need to be paid. One exception is that the Corps amount is set line item in the federal budget, so that has remained constant since '93. So that slice of the pie has shrunk while the other ones have grown. So I think the key sign that the program is working is that our budget has not survived these economic times that we're in, but it has even slightly increased. In 2013, those were increased slightly. The increases have not kept pace with inflation, so the program has actually shrunk in the last 10 years. But even the fees were flat for 2010 through 2012, but the steering committee did agree to increase fees in 2013, 14, and 15. Again, not keeping pace with inflation, but just any increase in this economic climate was hard to obtain, and it's a sign that the program is generating valuable information, and it's still considered a good investment. So what was needed to get going, help us learn how your program selects what to monitor and why. So again, money is the key to getting the program going. Stable funding really allowed the program to evolve and to flourish and become a model monitoring program. The first key to success, RMP, and I think of monitoring programs in general. The second one is having a clear focus on generating useful information, and this goes back to really trying hard to inform management decisions, and that's always helping us decide on which studies to fund. Collection has been important because in order to, especially between managers and scientists, because to identify what information is useful, you have to have the managers engaged and thinking hard about what they need, and not only, as I said, not only what they need right now, but what they'll need in 5 years or 10 years. As I'm trying to push them looking 20 years or 50 years out in the future. Science is really important. Working with top scientists is a great way to achieve sound science. Peer review is important. As I said, we've got it built in from all phases of the program. And of course, QA is essential for a good chemical monitoring program. Being adaptive is key. The program is very different from the program that began in 1993, or even the program that existed 10 years ago. And adaptive requires a great deal of effort, going into planning, and really engaged active participation by stakeholders. And communicating is getting that information out there and actually used. Want to see what the program is up to and how we're pricing things and selecting studies is to look at the new document that we generated this year called the Regional Monitoring Program Update. Another thing we've done to make our resource use more efficient is to not produce a full pulse every year, which is a pretty big effort. Another thing for this is Pulse Light. It's half as expensive as the full pulse, but it's got a different intent. It's intended to inform our stakeholders about what's going on in the program and what we've learned recently, where we're heading, and basically where the money is going. So what I want to do again, there aren't that many things that I think would want to do again. There's a little to come up with things, but there have been some studies that didn't pan out, and sometimes not through they're worth trying, but they didn't yield valuable information. Work that's not informing decisions. We gradually came to look at a lot of the status and trends monitoring is not really new knowledge that was helping us helping with decision making on things like metals in the water column or organics in water and sediment. So it's take a hard look at things and know when to pull the plug on studies that aren't really generating a lot of information that's being used. And then the bigger picture thing is the progress we've made in improving bay water quality has been a little frustrating. And just providing a perspective, this graph is from a talk put together for the State of the Bay Conference, State of the Estuary Conference last year, summarizing water quality in the Bay. And it's a visualization of water quality kind of from the maximum to a minimum, semi-quantitative, going back from before Europeans took over in the Bay Area. And basically, water quality, as population increased, water quality declined. The little blips are big oil spills. Things went downhill after the war, and the sediment cores showed large peaks of contamination in this time period. And things really bottomed out in the 60s when the bay was considered a cesspool, and we had a huge oil spill outside the Golden Gate. So this was about the bottom here. And then 1972, with the Clean Water Act, waste treatment improvements started to have an effect, and there was a huge improvement in water quality in the 70s and 80s. Now, unfortunately, from sort of the perspective of seeing improvement, my career started in 1986 on the Bay, and it's been a relatively flat period. There have been pollutants that have come and gone, like diazinon. Copper was a big concern in the 90s, but not so much anymore. Been some good actions taken there. Some things, there have been some big changes, like the suspended sediment and phytoplankton changes. The Corbula invasion was huge. But all the pace of improvement has been slow in the past 20 years, and would be nice if it was improving more rapidly. So about other programs, basically we're always looking to improve. So approaches that are effective both in technical areas and then in program and communicating to stakeholders. So at the end of my slides, I can take questions now. You can get all information, tons of information at the RMP website, at the shown here. And you can, if you have after today, if you have questions or would like copies of reports or to be on the RMP distribution list, just shoot me an email. So I can.
Yeah. Send in your questions to Jay via the chat box. You can unmute your phone by pressing *6 and ask your question directly.
Hi, I have a question. Can you hear me?
Hi, Lillian.
San Diego Water Board. I have a couple of questions. One is, are you also looking for phosphorus? Because from what I saw, you mostly look at. Another question is the program program?
I'm sorry, the second question. You got cut off.
I'm also supported swamp, basically.
It was choppy. Is the RMP supporting swamp?
No, it's RMP.
Sorry, I'm not able to hear what you're saying. Can someone else hear that? Some part I can add? Well, I can try to answer the phosphorus question. Yeah, I'm not hearing people talk about phosphorus, and the nutrient issue isn't one of my specialties, but it does. It's getting this same amount of attention, and I presume that's not really considered a limiting nutrient in the bay. Could you other second question, Lillian? Could other people? Or was it
I didn't hear anything either.
supporting the RMP? No, is the short answer. There's all these funds are separate from swamp funds coming from the dischargers into the RMP. There's some some collaboration that goes on, like with CETA. We coordinate closely with swamp, but there's no direct support. All right, well, there are no questions.